Hey, what's going on, guys? Let's look at this problem right here. Here we have a first order linear differential equation, but this is not in standard form. The standard form of the first order linear differential equation should look like this. We had to have dy dx, and then we had to have a function of x. We call this one p of x, and that one should be multiplied by y, and that is equal to a function of x. This is a general pattern of the standard form of the first order linear differential equation. Now if you look at this one, here we have x dy over dx plus 2y is equal to this one. But in standard form, we have to have 1 in front of this dy dx. But here we have x. So we have to get rid of this x. In order to get rid of this one, we divide everything by x. If we divide that one, what we will get for this one, this is going to become dy over dx plus 2 over xy. And then we will have x power minus 3 divided by x. That's going to become x power minus 4. Now after we bring this one into standard form, the next thing is we have to find out the integrating factor. So integrating factor is we have to bring the p of x, and we have to find the integrating factor. Using this formula, mu is the integrating factor, that is equal to e power integral of p of x dx. And we have to know that p of x is whatever the value that's multiplying y. Here 2 over x, that's the one multiplying y and at this location. And here you can see it's exactly at this location. So this is our p of x. Now let's go ahead and calculate p of x. Mu is equal to e power integral p of x is 2 over x dx. Now since 2 is a constant, I can move this one to the front. So 2 integral of 1 over x dx. And we know that integral of 1 over x dx is ln of x. So this is going to be e power 2 ln of absolute value x. And we will have a constant, but don't worry about the constant when you do the integrating factor, because if you do that, anyway, if you write the constant, like we will have a plus c. When we have plus c in the power, it means multiplied by e power c. But when we multiply this integrating factor in both sides, the constant is going to cancel anyway. So we don't have to worry about this constant. So don't worry about this constant. Now what is going to be this one? We can simplify this one. Like we can bring this 2 to here and write it as ln of absolute value x square. And in that way, we can write this one in simple way like x square. And then e and ln cancels each other. We will get absolute value of x square. But here also we don't have to worry about absolute value. It's not because of the x square. No matter what value you get, the absolute value doesn't matter, because it's also same approach. Like absolute value mean what? It can have positive value and negative value. If you bring the negative value and if you consider it's negative x square and multiply both sides of this equation, the negative is going to cancel and it's going to end up with positive anyway. So we don't have to worry about this negative value. So whenever we have absolute value like this, we can write it as x square. Okay, now x square is our integrating factor. After we find out the integrating factor, we have to multiply the integrating factor both sides. When we do the multiplication, that's going to give us dx square dy over dx, and here we will have plus 2x, because one of the x cancels, 2xy, and then here we will have x power minus 3. Now the reason for integrating factor is when we multiply by integrating factor, we can get rid of this part, right? Because if you bring, we can rearrange this one and write it like this, d over dx, and I bring this y to the inside, y x, or you can write x square y. And if you do the derivative of this one, this will be a product rule and you will get this back. That's the reason of integrating factor, because when you multiply both sides by integrating factor, you can bring it in this simple form. And if you want to see, you can try the product rule, you will get this one back. Okay, now we can say this is equal to x power minus 3. Now we have to integrate both sides with respect to x. So here we do the integration with respect to x. Here also we do the integration with respect to x. If you do the integration with respect to x in this side, since we have a derivative and integral, both are going to cancel each other. So this is going to be just x square y. In the other side, we will have x power minus 4. No, not minus 4, because we have to add 1 to the power. So this is going to be x power minus 2 divided by -2. Okay, I think I made a mistake here. Let me double check. Okay, we are multiplying here by x square, so this should be x power -2. Okay, this is a mistake, x power -2. So if you do the integration, this is going to become x power -1, because we add 1 to the power, x power -1 divided by -1. So we can just write minus x power -1, and also we will have a constant. Okay, we will have constant both sides, because but we can combine both of the constant together and write it in one side. In that way we will have a constant like this. Now finally we have to write our answer in terms of y. So we have to divide both sides by x square. If you divide this side by x square, that's going to be just y. If you divide this one by x square, that's going to become x power -3 and plus c over x square. And this is going to be the general solution for this differential equation. Since they don't give the initial value, we don't have to worry about the particular solution. So whenever we have something like this, we just have to find out the general solution, and that's it. I hope this helps. Thanks for watching. Don't forget to subscribe. See you next time.